Recently, I've read several books on the channel that have mentioned the term fourth dimension. And so I'm down another rabbit hole only to discover that, to date, depending what context the word is used, this might be one of those roads less traveled. As we try to connect spatial dots of the mind of man from 1913, which is the time this book was published, and assess if we've gone any further into discovery of the fourth dimension today. This book is titled A Primer of Higher Space, The Fourth Dimension by Claude Bragdon. Currently, as I mentioned, it depends on the context that we use this term. Scholars say that a fourth dimension does exist. In physics, the fourth dimension is time, or as some refer to it as space-time. In mathematics, it can refer to a hypothetical fourth spatial dimension, a fourth spatial dimension concept which is explored in physics and mathematics, but there is no direct experimental proof of it. Unlike time, which is a fundamental part of our reality as described by Einstein. In his theory of relativity, he said that the measurement of time is not absolute but is relative to the observer's motion and the gravitational field they're experiencing. And many of us can understand that, which means that time can be measured differently by observers in different frames of reference. So if one moving close to the speed of light versus one who is stationary. And he added that the presence of a massive object can cause what is termed time dilation. He demonstrated that because the speed of light is constant, time itself must be relative. So for an observer, a moving clock will appear to tick slower than a stationary clock. And I left in the link of the description of this video a video where there are a panel of scientists explaining this. So make sure to check it out. Now keep in mind that by dimensions, we're talking about length, width, and height normally, and the author is inviting us to explore beyond that. The curiosity of wanting to know what is beyond this third dimension, what is beyond what we know, has led some scholars to look into the theory of block universe. And that is said to be a model of space-time that treats time as a fourth dimension. All of past, present, and future exist simultaneously. Yeah, some of these sci-fi stories, right? In the block universe model, the universe is a static four-dimensional block containing all events, and our perception of time flowing is an illusion. This concept is supported by Albert Einstein's theory of relativity, which unifies space and time into a single continuum. Scholars propose that the subjective experience of a moving present is an illusion, as there is no universally privileged moment in time, similar to how there's no privileged position in space. This may not be of interest to everybody, yet for those interested in understanding what all we are capable, these types of topics may pique interest, as it does to me. I don't need to be a scientist or a mathematician or a physicist to sit at the table. My curiosity, imagination, and an innocent resolve to question what I don't understand gives me and you VIP pass to sit at the table with the best of them. If a block universe theory is supported by Einstein's theory of relativity, so according to scientists they say it does, then would that explain other phenomena such as retrocausality, suggesting that future events can influence past events? A possibility that is not ruled out by the block universe theory, because all moments, past, present, and future, coexist. And then this would add more exploration into the phenomena like quantum entanglement, where a measurement at a future point in time can seem to influence the state of a particle in the past. And so, being psychic is not such a far-fetched thing, but perhaps an ability that we've forgotten how to use. The author invites us to use the imagination as he builds up his explanation of the systems of 1, 2, and 3 dimensions, and once having laid that out, he goes further to explore via analogies and mathematics through the camp of geometry, the fourth dimension. From dots to lines and planes, he invites our imagination to see the invisible geometry of what bounds the third dimension to the fourth. And if you're patient with yourself, you'll begin to feel your own mind expanding and able to see that actually unfold before your own mind's eye. So it appears to me that as the author nears the end of this essay, he begins to make biblical associations with his fourth dimensional explanation. I don't know if he was trying to introduce concept of sacred geometry, attempting to reveal a divine creator using geometry and showing how these patterns reflect divine order and harmony. And again, I will say, if you are a truth seeker, you will find a golden thread that will help you on your quest as you construct the remembering. I love that word, remember, like connecting yourself back to what you used to be, of this beautiful tapestry called life. These concepts sometimes may appear antiquarian, as many of the books that I bring to this channel, and that's what I use to think about these things. But I'm learning that the more I delve into these old books, the more of the great puzzle I'm able to understand. And I'm able to see where some lies have been injected. And I hope that this is the same for you. If anything, we definitely have to be custodians of the great library. And as I approached the end of the book, I began to see the fine line between math, or the branch of geometry, science, faith, and imagination. Welcome. I am Daisy, your hostess. I now turn the page. A Primer of Higher Space, The Fourth Dimension, by Claude Bragdon. Foreword. The fourth dimension of space is a memory-haunting phrase, often heard, yet little understood. In this slender volume, the author has attempted to explain what is meant by it, and to usher the reader into some of those fascinating halls of thought to which it is the door. Although the exposition is a long known and already conventional lines, it is hoped that there is enough new and original matter to justify the book, and enough simplicity of presentation to justify its title, A Primer of Higher Space. The Fourth Dimension. The fourth dimension, the indispensable analogy. Adventure with me down a precipice of thought, sustained only by the rope of an analogy, slender but strong. This rope, anchored in the firm ground of sensuous perception, extends 3 paces in the direction of the great abyss, then vanishes at the giddy brink. Let us examine this sustaining simile foot by foot and strand by strand. Familiar both to the mind and eye are the space systems of 1, 2, and 3 dimensions. That is, lines, planes, solids. Lines are bounded by points and themselves bound planes. Line-bound planes, in turn, bound solids. What then do solids bound? Here's where the analogical rope vanishes from sight. If you answer that a solid cannot be a boundary, we part company. No argument of mine can convince you to the contrary. But if you are interested enough to ask, well, what do solids bound? A logic complains the answer. Higher solids, 4-dimensional forms, invisible to sight, related to the solids, we know as these are related to their bounding planes, as planes to their bounding lines. Let us retrace our steps and go over the ground again. A point moving a given distance in an unchanging direction traces out a line. This line, moving in a direction at right angles to itself, a distance equal to its length, traces out a square. This square, moving in a direction at right angles to its plane, a distance equal to the length of one of its sides, trace out a cube. It is easy to picture these processes and the resultant geometrical figures of 1, 2, and 3 dimensions, because the line, the square, and the cube have their correlatives in the world of objects. But the imagination fails when the attempt is made to continue this order of form building. Here again, the rope disappears into the void. For the cube to develop in a direction at right angles to it every dimension, a new region of space would be required, a 4th dimension. Should you declare that there is not and cannot be such a region of space, I wave you farewell as before. But if you hesitate, I cannot forbear to press my advantage. In such a higher space, the cube would trace out a hypercube or tesseract, a four-dimensional figure related to the cube as the cube is related to the square. This figure, invisible to the eye, is known to the mind. The number of its points, lines, planes, and cubic boundaries, and their relation to one another are as similar to the mathematician as are the elements of the cube whence it is derived. Footnote: the hypercube has 16 corners, 32 edges, 24 square faces, and 8 bounding cubes. End footnote. Again return, and for the third time. Arithmetically, it is possible to raise a number to any given power. That is, to multiply by itself any number of times. There is a known spatial correlative of the second power of a number, the square, and of its third power, the cube. But we have no direct or sensory knowledge of that analogous form, the tesseract, which would correspond to the fourth power of a number, nor of the four-dimensional space in which alone its development would be possible. With the geometry of such a space, mathematicians long have been familiar. But is there such a space? Is there any body for this mathematical soul? The reasonableness of the higher space hypothesis. Before dismissing such an idea as absurd, let be remembered that the mathematician is today the scout of science. Of this fact, the discovery of Neptune is a classic example. A French mathematician computed and announced the place of a hypothetical body exterior to Uranus. A German astronomer pointed his telescope towards the designated quarter of the heavens and found an object with a planetary disk not plotted on the map of stars. It was the sought-for world. May not the preoccupation of mathematicians with problems involving a hypothetical space of four dimension anticipate the discovery and conquest, not a new world, but a new space? The existence of a space of four dimensions can never be disproven by showing that it is absurd or inconsistent, for such is not the case. Not only has the higher space hypothesis such validity as the great law of analogy can give, but it involves many of the problems and reconciles many of the contradictions which confront the modern man of science. So true is this that Helmholtz continually kept the possibility of physical higher space before him in his dynamical reasonings, which are among the classics of physical science. Calvin also felt the pressure of the mathematical reality of higher space so strongly that he declared himself ready to accept it as an explanation of physical phenomena when these could be more consistently explained by such a concept. The idea that space may have more than 3 dimensions may seem highly revolutionary, but it is no more so than the idea that the world is spherical instead of flat, or that the earth revolves around the sun instead of the sun around the earth. These familiar and established truths contradict the evidence of the senses, and therefore they were received with incredulity until the proof of them became overwhelming. Should the evidence in favor of many-dimensional space become overwhelming, we should be forced to accept the idea and come to think in terms of it. In other words, if we came to observe in space contradictory facts, and if these facts forced us to ascribe to a body 2 attributes or qualities which were formerly thought could not exist together, our reason would seek to reconcile these contradictions. If the idea of a 4th dimension reconciled them, we should develop a sense of higher space. The 4th dimension defined. The expression, the 4th dimension, offers a shock to the mind accustomed to practical handling of matter, because all our experience of measurement or dimensionality are ultimately founded upon matter possessing but 3 dimensions, so that we have great difficulty in accepting the reality of a direction not contained in our space or our matter, but definitely at right angles to every line that can be drawn within the matter and space which contain all our ordinary experiences. Our idea of space is partial and like many another of our ideas, needs modification to accommodate it to fuller knowledge. What we think of as space is more probably only some part of space made perceptible. It may be that our space bears a relation to space in its totality analogous to that which the images cast by a magic lantern bear to the wall on which these images are made to appear. A wall with solidity, thickness, extension in other and more directions than those embraced within the wavering circle of light which would correspond to our sense of cosmos. In other words, perhaps that which we think of as space is only so much of it as our limited sensuous mechanism is able to apprehend. For knowledge arises from consciousness, and consciousness everywhere and always is conditioned by the vehicle of physical perception. The particular space or dimensional order apprehended by consciousness must bear an exact relation to the amplitude of motion in space of which the vehicle is capable. As this amplitude of motion varies widely in different departments of nature, there naturally arises the idea of spaces of different dimensionalities, each added dimension corresponding to a power of motion in a new direction. The grub, working its way upward out of the earth in which it is buried, may be said to inhabit a linear or one-dimensional space. The caterpillar's space, the surface of a leaf, is two-dimensional, while the winged butterfly attains the freedom of all three dimensions. Understood in this way, as new powers of movement in new media, the expression, the fourth dimension of space, is sufficiently descriptive as an unfamiliar power of movement in an unknown medium, but related to the movements and the media known to us by an orderly sequence of evolution. The designation of things in terms of their dimensionality. One other apparent contradiction in the use of terms, involving the possibility of misconception, should also be mentioned. In any discussion of the higher space hypothesis, such expressions as a one-dimensional body or a two-dimensional body are apt to occur. Such terms, though convenient, are not accurate, because there can be no such thing as a one-dimensional or a two-dimensional body in our three-dimensional space. Its three dimensions must exist always and everywhere, and everything must have some extension, however slight, in every one of its three dimensions. This is clear, even axiomatic, and the case must be the same if space has more than three dimensions. Whatever the number of dimensions in space, everything must have that number of dimensions too. If there are more than three dimensions in space and we perceive only three in the objects around us, then we are forced to the conclusion that we perceive things only partially. All the dimensions beyond the third are for us non-existent, but our lack of perceptive power does not in any way affect the objects themselves. Notwithstanding the self-evident fact that the number of dimensions in an object must be co-equal with the number of dimensions in space itself, there is a sense in which such expressions as a one-dimensional or a two-dimensional body have quite sufficient validity. They may be used to designate first a cross-section, limit, or boundary. The edge of a razor would be one-dimensional in this sense, and the surface of a table two-dimensional, and second, to designate something in which the given number of dimensions is patent and any dimensions beyond these latent, or in which the constituent particles have or appear to have free movement or power of transmission in the designated number of dimensions and restricted movement in all directions above and beyond that number. Understood in this way, a nerve, a hair, the stem of a leaf, the trunk of a tree, even might properly be called one-dimensional. A leaf, a handkerchief, a piece of paper, two-dimensional, and any solid of our space three-dimensional. For there is a perfectly appreciable difference, based upon extension in space, between these various classes of objects, notwithstanding that all of them have, as we know, extension in all three dimensions, and according to the higher space hypothesis, in more than that number. A broader concept of space. Having now in a manner paved the way, let us put aside all our preconceived ideas as to the limitations of space, and form a new concept which will embrace the higher dimensions as easily as the lower. It is necessary to do this not because our space conception is false, but only because it is partial. Let us think not of abstract space, but of material spaces differentiated from one another by their dimensionality and designated in terms of it as a 1 space, a 2 space, a 3 space, a 4 space, and so on. The greater the number of dimensions, the higher the space. Let us think of each space as generated from the one next below it, and as having the dimensionalities of all spaces lower than itself patent, and those higher than itself latent. Also, conceive of each space as the cross-section of the next higher space, as limiting two contiguous portions of higher space. For example, one segment of a line, a one space, is divided from another by a point, and the line itself is generated by the motion of a point. One portion of a plane, a 2 space, is separated from another by a line, a 1 space, and the plane itself is generated by the movement of the line in a direction at right angles to its length. Again, two portions of a solid, a 3 space, are limited with regard to one another by a plane, a 2 space. This plane, moving in direction at right angles to the surface, generates a solid, a 3 space. Also, by analogy, two portions of a higher solid, a 4 space, are limited with regard to one another by a solid, a 3 space, and this solid, moving in a direction at right angles to its every dimension, generates a higher solid. From this, it is possible to formulate a definition applicable to a space of any dimensionality. A space is that which separates two portions of the next higher space from each other. Also, any space can generate its next higher space by moving in a new direction, that is, a direction not contained within itself. A hypothetical two-dimensional universe. With these axioms as a guide, let us by a simple expedient try now to gain some elementary notion of four-dimensional space, undisturbed by any apparent absurdity in the idea. Consider our three-dimensional space as the higher space of a two-dimensional world of similar form and constitution to our own. Now, by the terms of our definition, a two-dimensional universe would be a plane separating two contiguous portions of universal three-dimensional space from each other. This plane, to have concrete existence, to be anything more than a geometrical abstraction, would need to have some thickness, some extension, however slight, in the third dimension. A terrestrial world in such a two-dimensional universe would not be a sphere, as in our 3 space, but a circular disk, the cross-section of a sphere. The matter of this disk world would have the power of free movement in the two extended directions of the plane, its space, but no power of movement in the infinitesimal or third dimension. Assume that this disk world is held together like our own by an attractive force analogous to gravitation, which not only determines and preserves its circular form, but holds its inhabitants, two space men, to the rim which forms its surface. Such a two-space man would bear the relation to a human being that a cross-sectional slice of a solid bears to the solid itself. What account would this flat man on the rim of this disk world, traversing his plane space, give of the universe in which he finds himself? The direction of the attractive force holding him to the rim of his disk, the surface of his earth, would give him the sense of up and down, the eerie region above his head and the earthy region beneath his feet, thus determining for him one dimension of his plane space. Also, since he can move forward and backward along that rim, he would be conscious of a direction parallel to the circumference, the second dimension. But being denied any further power of movement, he would have no knowledge of right or left, the third dimension, for this direction would extend into his higher or three-dimensional space. Suppose him to be inspired by some intimation of this higher space, as we are beginning to be inspired by intimations of a space higher still. In what form would the apprehension of it enter his limited consciousness, and how would it affect his concepts? He would come to conceive that the conditions of his existence demanded the presence of an extended wall of matter everywhere in contact with the objects of this world. He would infer also that these objects must have an imperceptible thickness in the higher dimension, that they might indeed conceivably, though invisibly to him, extend away into it. What seemed to him to be the solids of his world might be, in fact, the two-dimensional boundaries or cross-section of three-dimensional solids, in or passing through his space, in the same manner that in his world a one-dimensional line would be recognized as the boundary or cross-section of a two-dimensional square. Reasoning along these lines, he might conclude that he himself was but a two-dimensional cross-section of some three-dimensional body, the corporeal part of a higher being inhabiting three-dimensional space, and the sublime faith might grow up in him that his unified consciousness had its home in planes of existence, the nature of which, by his physical limitation to two dimensions, he could not be aware. Deductions from foregoing premises. If this train of reasoning is logical for a two-space man, exactly analogous suppositions may be formed by us with regard to four-dimensional space. We have a right to infer that our space is, as it were, an interval, a gap in higher space. We may believe that there is a direction extending at right angles to every direction that we know, that our world and everything in it is sustained and environed by this boundary. We must, however, give up any attempt to picture to our imagination this four-dimensional space. We can no more do so than the flat man can imagine the three-dimensional space contiguous to his own. We cannot point to it any more than the two-space man can point to his right or to his left, because it involves a power of movement which we do not possess. We may suppose that in some way unknown to us all the objects of our world have an infinitesimal thickness in the higher dimension, that they are in reality three-dimensional projections or cross-sections of higher solids traversing our space. We may conclude, indeed, that our physical bodies are such projections of higher bodies, still our own, and that our essential selves have their home in planes of being, the nature of which, by the limitation of our consciousness to three dimensions, we cannot be aware. It may be urged that the cross-section space world man first described has nowhere any existence, and that the whole concept is a figment of the imagination, and that conclusions based upon premises of this order are entitled to no consideration. It is true that we know of no two-dimensional space, world, or beings such as have been described. The whole analogy is an artifice, a false work, constructed for the purpose of acquainting the reader easily and rapidly with certain fundamental higher space concepts. But these conclusions, though deduced from premises avowedly artificial, are not for that reason necessarily false. They are not solely sustained by means of this flimsy scaffolding, but rest upon other and firmer foundations, as will be shown. A physical two-dimensional system. And yet this particular scaffolding is not quite so rickety as it appears. A study of nature from the standpoint of the higher space theory, that is, the consideration of it as an aggregation of material spaces of different dimensionalities, brings to light many systems resembling in their essential elements the hypothetical one above sketched. Recollect first that space, as the word is here used, is the space of the physicist rather than that of the geometer. Space should be conceived as a concrete and relative, not as abstract and absolute. With this idea in mind, and granting that all life manifesting as motion is conscious life, as much aware of its environment as the limitation of its motion permits, let us see if we cannot find some combination of related spaces of different dimensionalities, actual, concrete spaces, which shall form a basis for deductions of the same order as those already made from imaginary premises. Since by the terms of our definition, a space is that which limits two contiguous portions of the next higher space, the surface of a pond or pool, limiting as it does the water beneath and the air above, would constitute a two-dimensional space limiting two portions of three-dimensional space from each other. A lily pad floating horizontally on this surface might be considered a world of this two-space, and its inhabitant some microscopic unit of consciousness free to move in the two extended dimensions of the leaf, but prevented by the thinness of its plane world from moving up and down, and therefore necessarily ignorant of everything above and below. Except for a change of axis, this corresponds in its essential features to the cross-sectional system first sketched, and nature abounds in such systems and sequences. The plane space, plane world, and plane-bound consciousness, so far from being arbitrary and absurd, are literally true in fact. The movable threshold of consciousness. Duprel says in his philosophy of mysticism, from the standpoint of every animal organism, we can divide external nature in two parts, which are the more unequal as the organic grade is lower. The one includes that part which the sense apparatus establishes relations. The other is the transcendental for the organism in question. That is, the organism lives in no relation to it. In the biological process, the boundary line between these two world halves has been pushed continually forward in the same direction. The number of senses has increased and their functional ability has risen. The biological rise and the rise of consciousness thus signify a constant removal of the boundary between representation and reality at the cost of the transcendental part of the world and in favor of the perceived part. Now, if this shifting psychophysical threshold is simply the dividing line between lower and higher spaces, then the whole evolutionary process consists in the conquest, dimension by dimension, of successive space worlds. This certainly holds true as far as our observation extends. To the grub, working its way up to the surface of the earth, that surface is transcendental. To the caterpillar, the earth is real and the free air transcendental. While to the butterfly, master of this added dimension, the threshold has again receded. Indeed, there are indications that the butterfly is in possession of a space sense, which is still a mystery to us. Faber himself cannot explain how the great peacock moth finds its mate in the dark and at a distance sometimes of miles. Arguing by analogy, everything which is to us transcendental exists nevertheless in some space. It is therefore possible that by an intention of consciousness we may be able first to apprehend, then to perceive as real, that which is now considered transcendental. The conquest of space by consciousness. Right at this point we cross the track of Plato. In one of the Platonic dialogues, Socrates makes an experiment on a slave who is standing by. He causes space perceptions to awaken in the mind of Minos' slave by directing his close attention to some simple facts in geometry. Plato's comment was that behind the phenomena of mind that Minos' slave boy exhibited, there was a vast and infinite perspective. It is possible that by dwelling on elementary higher space concepts, we may repeat Socrates' experiment on new grounds. That is, by an intention of consciousness upon the fourth dimension, we may push back the psychophysical boundary and capture for sense the now transcendental fourth dimension. Because this pushing back of the psychophysical boundary is incessant and universal, we have only to observe its lower and earlier manifestations in order to understand its immediate and ultimate. Such observation leads to the conclusion that our sense of time may be only an imperfect sense of space. This is clear if we consider the manner in which the facts of space must present themselves to a consciousness with a less developed sense of space than ours, and by less developed sense of space is meant a more limited power of representation in form. Many things which we as human beings apprehend without difficulty simultaneously after the manner of space, such a consciousness could only apprehend successively after the manner of time. A worm, for example, requires time in order to examine an angle or a hole, things in which with us the time element does not enter at all. Thus, that which is time to one grade of consciousness is space for the next ascending grade. If this is true, then, though the fourth dimension cannot manifest itself to our three-dimensional powers of perception as space, it can, and perhaps does, manifest itself as time. That is by means of changes of state in the objects of our world involving a temporal element. The fourth dimension as time. This is important. Let us see if we cannot realize it more completely and concretely. Think of the fourth dimension not as a new region of space, a direction has been said towards which we can never point, but as a principle of growth, of change, a measure of relations which cannot be expressed in terms of length, breadth, and thickness. Now go back to the consciousness limited to the two dimensions of a plane. The objects of our world, three-dimensional objects, passing through his plane world, would manifest their third dimension as a principle of growth, of change, and as a measure of relations which could not be expressed in terms of two dimensions. The changing cross-sections which they traced in the constituent matter of his plane in passing through would alone be in evidence. These, appearing waxing, waning, would seem to him to be the matter of his world in a dynamic condition, organized into forms mysteriously endowed with an inherent power of change, of expansion and contraction. Imagine, for example, a cone passed, apex downward, through a plane. It would appear there first as a point expanding into a circle, and this still growing circle would suddenly disappear. All of these modifications of form would be caused by the gradual involvement of the third dimension of the cone into the two dimensions of the plane. They would be a temporal expression of the cone's extension in that third dimension. This is a commonplace of science. All higher dynamical reasonings use motion as a translator of time into space or space into time. If, then, as thus appears, the third dimension could manifest itself to a consciousness limited to two dimensions as a sequence of changes in two-dimensional objects which require time for their unfoldment, then, by analogy, a fourth dimension, which would be spatial extension in some new direction at right angles to the three known to us, would manifest itself to our perception equally as a time change. What changes involving a temporal element might be regarded as significant of higher dimensionality? What but the universal flux of things, life, growth, organic being, the transition from simplicity to complexity, the shrinkage or expansion of solids? These would be, by this view, the evidence of a fourth dimension. They would be measurable only by means of it, since a temporal element is involved in every such change. One manner of conceiving the fourth dimension, therefore, is as space changing in time. We are to think of the physical universe accessible to our observation as possessing at least four coordinate, and interchangeable dimensions, of which 3 are included under the name of space, and the 4th is called time. If all movement in space were suddenly to cease, the 4th dimension would be eliminated from it. Fantastic as this idea may appear, it is exactly that which has produced interesting results in dealing with the problem presented by the ether of space. Mathematical physicists have found that apparent experimental contradictions disappear, and the mathematical framework of physics is greatly simplified if, instead of referring phenomena to a set of 3 space axes and 1 time axis of reference, they refer to a set of 4 interchangeable axes involving 4 homogeneous coordinates, 3 of space and 1 of time. Time, in other words, is employed as though it were a dimension of space, the 4th dimension. The history of higher space thought. While the higher space hypothesis is a flower of modern garden, it has its roots in the rich soil of the past. No great violence of invention is required to discover, as has been done, the idea of a higher space in the ancient wisdom of India and in the philosophical systems of Parmenides and Pythagoras. As C. Howard Hinton says, either one of the 2 things must be true, that 4th dimensional conceptions give a wonderful power of representing the thought of the East, or that the thinkers of the East must have been looking at and regarding 4-dimensional existence. Plato, in a famous passage in the Republic, shows that he held a precious secret in the hollow of his hand. Reference is made to the memorable allegory of the chained captives reduced to the denizens of a shadow world. All movements observed by them were but movements on a surface, and all shapes but the shapes of outlines with no substantiality. Plato uses this illustration to portray the relation between true being and the illusions of the sense world. It is a significant fact that the term quarta dimensio was used first by Henry More, the Platonist, about the year 1671. Kant not only recognized the possibility of the existence in space of more than 3 dimensions, but he inferred their very probable real existence. If it is possible, he says, that there are developments of other dimensions of space, it is also very probable that God has somewhere produced them. For his works have all the grandeur and variety that can possibly be comprised. Swedenborg's involved descriptions of heavenly forms, motions, and mechanics become somewhat more intelligible when interpreted in terms of higher space. It would appear that in common with many other seers, he knew only as much of 4-dimensional existence as fish know of water. They are unconscious of it because it is the medium in which they live and move. Certain modern researchers in these superphysical realms are aware of the unique character of their environment. One of them, Mr. C.W. Ledbetter, says, "I can, at any rate, bear witness that the tesseract, or 4-dimensional cube, is a reality, for it is quite a familiar figure on the astral plane." Modern science, to which testimony of this order has no validity because it is not susceptible of corroboration by the usual methods, has approached the subject of higher space along totally different lines. The notion of geometries of new dimensions, the geometry that is of higher space, began to suggest itself to mathematicians in the early half of the 19th century and has assumed an increasing importance ever since. Attempts to utilize the higher space hypothesis in the explanation of chemical and physical phenomena has served to bring the subject prominently before workers in these branches of science. And finally, because the hypothesis would account for many so-called psychic phenomena, it has been seized upon by the psychic researcher, hard-pressed for some quasi-scientific explanation of things the reality of which he cannot doubt. Research leads always into the profound. The light of things known serves but to reveal a greater abysm of mystery beyond the threshold of consciousness. The higher space hypothesis makes man, in his present estate, appear but as an earthworm in the power and knowledge Nevertheless, it holds out the promise of eternal progress. This next section will cover plates with their figures and descriptions. The generation of corresponding figures in 1, 2, 3, and 4 space. Figure 1. The line. A one-space figure generated by the movement of a point containing an infinite number of points and to form its boundaries. Figure 2. The square. A two-space figure generated by the movement of a line in a direction perpendicular to itself to a distance equal to its own length. It contains an infinite number of lines and is bounded by 4 lines and 4 points. Figure 3. The cube. A three-space figure or solid generated by the movement of a square in a direction perpendicular to its own plane to a distance equal to the length of the square. The cube contains an infinite number of planes, squares, and is bounded by 6 surfaces, 12 lines, and 8 points. Figure 4. The tesseract or tetrahypercube, a 4-space figure generated by the movement of a cube in the direction, to us unimaginable, of the 4th dimension. This movement is extended to a distance equal to one edge of the cube, and its direction is perpendicular to all our dimensions, as each of these 3 is perpendicular to the others. The tesseract contains an infinite number of finite 3 spaces, cubes, and is bounded by 8 cubes, 24 squares, 32 lines, and 16 points. Note, figure 4 is a symbolic representation only, a sort of diagram suggesting some relation we can predicate of the tesseract. Figure 5 is a representation drawn on a different principle in order to bring out a different set of relations. Plate 2. Correlations in form and space of some properties of abstract number. A number multiplied by itself gives the second power of that number, commonly called its square, by reason of its close relation to the geometrical square whose side contains the given number of units of length. The second power of 3 is 3 times 3, or 9. Figure 1 represents a geometrical square whose side is 3 units in length. Say 3 inches. The area of the square will obviously be 9 square inches. Side of square 3 linear units, area of square 3 square units. In figure 2, the edge of cube 3 linear units, face of cube 3 square units, volume of cubes 27 cubic units. So figure 2, let us now build up from the square to a height of 3 inches the cube represented in figure 2. The solid will obviously contain 3 by 3 by 3 equals 27 cubic inches. By analogy with the geometrical figure, the number 27, the third power of 3 is called, in arithmetic, the cube of 3. Now the 4th, 5th, and higher powers of a number are commonplaces of arithmetic. What do such higher powers mean in geometry? We cannot make complete physical representation of 4-dimensional solids in our 3 space, just as we cannot construct a cube in a plane surface, but we can make diagrams of hypersolids, and the properties of many such figures in hyperspace are well known, having been demonstrated like propositions in Euclid. Hyperspace is thus mathematically real, and the masterminds of science consider it to be physically possible, Lord Kelvin and others. Plate 3. the development of a unit of 2, 3, and 4 space into the next lower space and their expression in and by means of units of those lower spaces. If the bounding lines of the square A, B, C, D were made of a contiguous wire, and if that wire were cut at D, the boundary could then be bent down into line with AB, forming a one-dimensional figure of 4 linear units. The original linear unit, AB, having one linear unit at each end of it and an extra one beyond at one end. If the cube A, B, C, D through G were made of a continuous sheet of tin, and if that sheet were cut along certain lines formed by intersecting spaces, the whole could be folded down to form a two-dimensional figure of 6 squares. The square ABCD having a square on each side of it and one beyond in one side. Similarly, if the tesseract represented by the diagram were made of solid wood as to its bounding cubes, and if this wood were cut through the appropriate planes, the cubes could, by analogy, be folded down to form a three-dimensional figure out of 8 cubes. Plate 4. Corresponding developments and projections of a cube and of a tesseract in lower spaces. Figure 1. The cube, a 3-space figure, can be represented in a space of 2 dimensions in 2 ways. By showing its 6 faces as they might be folded down or developed upon a plane, or by a projectional drawing. The first method would show the squares without distortion, but could give small idea of their correlation into a unit, as in Figure 1. The second method indicates this correlation, but at the expense of making at least 4 of the 6 faces appear as rhombic parallelograms instead of as squares, as in Figure 2. The tesseract, a 4-space figure, can be folded down or developed into a 3-dimensional figure, or we might construct a 3-space projection of the 4-space tesseract by making, say, a model of wire in which the boundaries are correlated into a consistent figure, but in which at least 6 of the 8 bounding cubes are distorted into a parallelepiped. The 4-fold repetition of Figure 4 is for the purpose of exhibiting the 8 bounding cubes of the tesseract. Plate 5. The representation and analysis of the tesseract or 4-dimensional cube by a method analogous to that employed in making a parallel perspective. A glass cube held directly in front of the eye will appear as shown in the accompanying drawing. This, being a plane figure of 2 dimensions, might have been produced by drawing one square inside of another and then connecting the corresponding corners. This could be done without any thought of 3 dimensions, yet on this plane figure many of the properties of the cube can be studied by counting the 4-sided figures, which we find to be 6. We learn the number of faces of the cube by counting the number of corner points, which are 8. We learn the number of the corners of the cube by counting the lines, which are 12. We learn the number of the edge of the cube. In the same way that Figure 1 represents the cube, Figure 2 represents the 3-dimensional form corresponding to the tesseract, just as we drew a smaller square inside of a larger one. So we represent a smaller cube inside of a larger cube, and just as we drew lines joining the corresponding corners of the squares, so we form planes joining the corresponding edges of the cubes. To find the number of cubic boundaries of the tesseract, we count the large outer cube, the small inner cube, and the 6 surrounding solids, each a distorted cube, 8 in all. A further study of the figure discovers 24 planes, squares, faces, 32 edges, 16 corner points. Plate 6. The boundary between two adjacent portions of any space is in general a space of dimensions fewer by one. For the discussion of physical realities, we are to conceive each kind of space as possessing an infinitesimal small extension in the next higher dimension. A point or zero space divides a line or one space into two parts, figure 1. For our physical reasonings, we may take for the point a circle of 1/200 million of an inch diameter, about that of a molecule. The line A through B, figure 2, A, one space forms the boundary between two adjacent parts of the plane or two space C, D, F, E. Note that as the divided line, figure 1, is higher space to the dividing point, so the plane is higher space to the line that divides it and bounds the two adjacent portions. Again, the plane G, figure 3, a two space separates and mutually bounds two adjacent portions of the solid three space H, I, K, J, and L, M, O. Therefore, we have at least rigid analogy to justify us in saying that our three space divides hyperspace of 4 dimensions and mutually bounds two adjacent portions thereof. The point D is wholly contained in the line. Every point of the line AB is in contact with its higher space, the plane. Every part of the plane G is immersed in its higher space, the solid touching every point of the plane. Similarly, our 3 space as a boundary immersed in 4 space must undeniably be in contact at every point with that 4 space that is. The innermost parts of our solids are as open to touch from 4 space as are its boundaries to us. Plate 7. In general, rotation occurs in 2 space about a point, in 3 space about a line, and in 4 space about a plane. If two lines AB and A'(B' in the same one space are symmetrical in relation to a point 0 of the space, figure 1, AB cannot be so moved in one space that the corresponding points shall coincide. To effect such coincidence, it is necessary to rotate AB through 2 space, about 0, as a center, or roughly speaking, AB must be taken up into 2 space, turned over, and put down on B'A'. Likewise, if 2 triangles in the same 2 space are symmetrical with respect to a line, as in figure 2, coincide of corresponding points, and lines can be effected only by rotating one triangle through 3 space about the axis of symmetry. That is, one triangle must be taken up into 3 space, turned over, and put down on the other. Again, if 2 polyhedral figures in the same 3 space are symmetrical with respect to a plane, but not with respect to any single line or point, as in figure 3, coincidence of correspondence points, lines, and planes can be effected only by rotating one polyhedral figure through 4 space about that plane, or roughly speaking, one polyhedron must be taken up into 4 space, turned over, and put down on the other. A mirror image of a thing represents this kind of a revolution, impossible in 3 space. Plate 8. Symmetry in any space, the evidence of a higher dimensional action. It is readily conceivable that the 2-dimensional symmetry, which is so constant a characteristic of vegetable forms, may be the result of a rotation about a central axis of etheric particles in the dimension of space not contained within the plane of the petal or of the leaf, i.e., in its higher space. May it not be that the three-dimensional symmetry, which is so universally characteristic of animal organism, is the result of birotation, or revolution about a plane? The four-dimensional movement analogous to the turning about a line in three space? The right and the left hands, for example, may owe their correspondence of parts to a four-dimensional rotation in the minute invisible matter of our world. The effect of this kind of a motion would be such as the two hands show three-dimensional solids related to one another as object and mirror image. Figure 3 represents crystals of a tractate bearing the relation of object and image. If one changed into two without chemical resolution and reconstitution, it would indicate a fourth dimension. Plate 9. Lower spaces are contained in higher, i.e., in spaces having a larger number of dimensions, and the figures of such lower spaces have close relations to corresponding figures of more dimensions. Thus are found in lower spaces significant suggestions of higher. The circumference of a circle, considered simply as a line and as possessing but one dimension, presents few relations. The complete circle in the plane, however, in Figure 2, a two-dimensional figure, has a rich geometry on its own, treating of radii, tangents, chords, etc. In connection with three space, the circle has numerous additional and important relations with the sphere, cylinder, cone, etc. Figure 3. Any other figure-like matter gains immensely in interest when we consider the nexus of its relation with higher space. Furthermore, just as certain linear figures require three space for their generation, the helix, Figure 4, for example, in hyperspace, a wealth of new and interesting lines and surface are brought to light. The following concrete illustration may help to summarize the foregoing ideas in the mind. The path of a man moving across a huge sheet of ice represents roughly a line contained within a two space, the Earth's surface. This surface, being the boundary of the Earth's sphere, requires, like the helix, the scope given by three space for its description. Now, owing to the travel of the sun towards the constellation Hercules, the Earth revolves about the sun not in a plane, but in a helix. Moreover, the whole starry universe may be sweeping along a path of which the fourth dimension is a component. Plate 10. Four-dimensional space extends away in a direction at right angles to all directions in three-dimensional space, which is therefore exposed or open from the region of the fourth dimension. A point starting from the center of a line, a one space, and moving off in a perpendicular direction into a plane, a two space, will not approach any portion of the line. See Figure 1. A point starting from the center of a circle, a two space, and moving off on a line perpendicular to its plane will not approach any portion of the circumference of the circle. Figure 2. A point starting from the center of a sphere, Figure 3, and moving off on a line perpendicular to our space will not approach any part of the surface of the sphere, but will move away at the same rate from all points of this surface. Because analogy requires that the boundaries of hypersolids, portions of four-dimensional space, be three-dimensional, it therefore follows that each point within a solid is all that in its place separates the two portions into which the three space of the solid divides four-dimensional space. Each point is thus the beginning of a pathway into and out of four-dimensional space. Does the individual clothed in its four-dimensional vehicle forsake the physical body at death by this route? Does an obsessing entity capture the physical body of another during the temporary absence of its rightful tenants by entering through the unguarded gateway of the fourth dimension of space? Plate 11. Each space or dimensional order contains an infinity of spaces of dimensions fewer by one, and is itself one of an infinite number of similar spaces contained within a space of dimensions greater by one. A line contains an infinite number of points, as in Figure 1. A plane contains an infinite number of lines, 1 spaces, as in Figure 2. A solid contains an infinite number of planes, 2 spaces, as in Figure 3. By analogy, an infinite number of solids, 3 spaces, would be contained within a hypersolid, a 4 space. If, as philosophers affirm, the visible world exists only in and for consciousness, if it is but the perception of a perceiver, then for each conscious person there exists a different world. It follows logically that these countless personal consciousness in which the three-dimensional perception of the world inheres may be thought of as so many 3 spaces going to form a higher or 4-dimensional unity, the consciousness of humanity as a whole. For it is clear that humanity is higher dimensional in relation to the individual man if we consider humanity in its totality. It has powers of which no single human being is possessed. It is both old and young, yet deathless. It is in all places at once. It sees all objects, hears all sounds, thinks all thoughts, experiences all sufferings, all delights. Now suppose a man to dwell constantly in the thought of this humanity, to identify all his interests with its larger interest. Is it not thinkable that he might transcend the personal limitation and merge himself into the larger consciousness of what he has all the while been a part? Plate 12. The representation of the form of an object is conditioned and restricted by the space in which such representation occurs. The higher the space, the more complete the representation. For example, the sphere, a 3-space form, can only be represented in plane space by a circle of a diagram equal to the diameter of the sphere, and in linear space by a line of a length equal to the said diameter. These lower dimensional representations may be conceived of as the shadow cast by higher space forms on lower space worlds. The sphere A casts the circular shadow B upon the plane C, and the linear shadow D upon the line E. Of what, then, is the sphere itself, in this sense, the shadow? The hypersphere related to the sphere as it is related to its circle of greatest diameter. Man, a higher dimensional entity, representing himself through lower dimensional world, is pursued by the necessity of his shadow or personality in A. Plate 13. A number of dissimilar geometrical figures are susceptible of being correlated and combined into a single higher dimensional form. This fact, as regards 2- and 3-dimensional space, is well illustrated by means of the following puzzle problem. Question: what form of a wooden stopper will answer equally for 3 holes in a board? 1 in the shape of a circle, 1 a square, and 1 a triangle, Figure 1. Answer: a stopper which will fill any of the 3 holes is a wedge-shaped solid having a circular base, 1 square section, and 1 triangular, as in Figure 2. By analogy, the 3-dimensional correlatives of the circle, the square, and the triangle, namely the sphere, the cube, and the tetrahedron, might be boundaries and cross-sections of some single 4-dimensional form, of which such figures as the cylinder, the prism, and the pyramid might also be projections. If the personality is the projection on the physical plane of the individuality or higher self A single individual might project itself in many different personalities, separated from one another in time. Reincarnation may thus be conceived as the successive representations of a transcendental self. Plate 14. The fourth dimension may be manifested to us through certain motions in our space of 3 dimensions by translating itself for our experience into time. This is best illustrated by considering first the same truth in terms of lower space, the line AB having extension in the dimension not contained in the 2 space C, D, E, F, moves in this additional 3rd dimension. Downward to it, the point P where the line penetrates the plane moves to the left from Y to Z, and the time required to complete this motion from Y to Z in 2 space measures the extent perpendicular to the plane of the line AB in the uncontained dimension. That is, the time measures AX. The sphere in figure 2 in transit across a 2 space represented by the plane CDEF would manifest itself in the plane as a point, expanding to a circle which would attain a maximum diameter equal to that of the sphere, after which it would shrink to a point and disappear. Similarly, a hypersphere or a 4-dimensional sphere of radius r passing through our space would appear to us as a sphere with a radius gradually increasing from 0 to r and then gradually decreasing from r to 0, as in figure 3. The phenomena of life growth are significantly suggestive of 4th-dimensional entrances upon 3-space experience. Plate 15. The density of bodies, an indication of a pressure from the direction of the 4th dimension and a measure of extension in that dimension. A stream of water falling vertically upon a plane's surface tends naturally to spread out in the 2 dimensions of the plane, setting up in so doing undulations in the shape of enlarging concentric circles, diminishing as to depth. The rapidity of this lateral extension and the force and height of the waves will depend upon the height from which the stream of water falls, that is to say, upon its pressure in the 3rd or vertical direction, as in figure 1. Carrying out the analogy, in our world of 3 dimensions, the expansive force of gases would be due to some similar influx from the region of the 4th dimension, and the amount of pressure exerted by a gas would be a measure of 4-dimensional extension. So long as the quantity of energy coming down from a higher world is not expended, there would be some degree of force entering by way of the 4th dimension, which causes the gas to dilate in our 3-dimensional world. The capacity of a gas to extend comes thus from a 4-dimensional world. The density of solid bodies would be due to the same cause, with this difference that they are stable and cannot dilate. That is to say, they are in equilibrium with atmospheric pressure. As a consequence, the variations in the densities of bodies would be due to variations in the force exerted from the 4th dimension. The 4th dimension can thus be considered as represented by the density of solids or by the expansive force of gases. Plate 16. Evolution interpreted in terms of higher space. If we pass a helix, a spiral in 3 dimensions, through a film of 2 space, the intersection will give a point moving in a circle, as in figure 1. If the helix remains still and the film moves vertically upward, the spiral will be represented in the film by the consecutive positions of the point of intersection. In the film, the permanent existence of the spiral will be experienced as a time series. The record of traversing the spiral will be a point moving in a circle. It is easy to imagine complicated structures of the nature of the spiral, structures consisting of filaments, and to suppose also that these structures are distinguishable from each other at every section. If we consider the intersections of these filaments with the film as it passes to be the atoms constituting a film or universe, we shall have in the film a world of apparent motion. We shall have bodies corresponding to the filamentary structure, and the positions of these structures with regard to one another will give rise to bodies in the film moving amongst one another. This mutual motion is apparent, merely the reality is of permanent structures stationary, and all the relative motions are accounted for by one steady movement of the film. Now imagine a four-dimensional spiral passing through a three-dimensional space. The point of intersection, instead of moving in a circle, will trace out a sphere, assuming, as before, a complicated structure for the spiral. Its presentment in three space will consist of bodies built up of spheres of various magnitudes moving harmoniously amongst one another and requiring time for their development. May not the atom, the molecule, the cell, the earth itself, be so many paths and patterns of an unchanging unity? Plate 17. Lower space systems in our world. Higher space speculation is largely based on the analogy supplied by a hypothecated two-space consciousness limited to the two dimensions of a plane, or by a one-space consciousness confined to a line. Have such conditions of existence any reality? For if they have not, it is useless to attempt to prove by them the reality of a four-dimensional world. If, as seems probable, all life is consciousness, as much aware as its spatial limitations permit, nature everywhere abounds in such lower space systems. They stand exhibited indeed in nearly every plant that grows, for the point, the line, the surface, and the sphere in seed, stem, leaf, and fruit appear. A tomato plant, exemplifying a system of lines in its stalk and stems, a system of planes in its leaves, and a system of solids in the fruit. In other worlds, a 1, 2, and a 3 space world. Although such lines and planes are really three-dimensional, they yet fulfill the conditions and conform to the definition of lower spaces, which do not preclude extension in higher dimensions, so long as there is little or no freedom of movement therein. In stalks and stems, the free movement of particles is restricted in all directions save one. In leaves, it is restricted in the third dimension. In this plate, we have figure A, a snow crystal, figure B, nasturtium leaf, figure C, human hand. A consciousness contained in such a form as A would in effect inhabit A, one space, B, a two space, and C, a three space. Plate 18. An interpretation of certain so-called psychic phenomena in terms of the higher space theory. Figure 1 and 2 is apparition in a closed space. Figure 1 represents what would correspond in two space to a one-room house to enter it without passing through any of the breaks in the perimeter representing door and windows. Would constitute a psychic phenomena in two space, but it could be entered by way of three space by a revolution about the line of one of its sides. Similarly, a three space house, as in figure 2, might be entered by a four-dimensional rotation about the plane of one of its sides. Possession, obsession, automatic writing, and allied phenomena are susceptible of explanation by means of the higher space hypothesis. It is also necessary to realize that from the higher region of space, the interior of a solid is exposed as the inside of a plane figure is exposed from the region of the third dimension. The heart could be plucked from the body without breaking the skin. An alien invading will clothed in matter capable of a four-dimensional rotation might thus possess itself of the hand or brain. Clairvoyance in space, as in figure 5 and 6. Imagine a city in two space with houses similar to figure 1 to normal two-space perception. They would appear as in figure 5. Only the lines forming the walls visible, the nearer ones concealing all those more remote. By rising in the third dimension, the field of vision would enlarge so as to include the entire city of houses. The interiors would then become visible. Though obliquely from high overhead, the interiors would open broadly into view. Correspondingly, by moving out of 3 space into 4 space, the field of perception would expand cubically, and the interiors of all 3 space solids would stand revealed, being exposed in the region of the 4th dimension. Plate 19. Man is seen by clairvoyant, 4-dimensional vision, and by ordinary human sight. A 2-space man inhabiting a plane would see only the lines bounding the solids, plane figures of his world. A 3-space man sees the enclosed surface as well as the boundaries of such 2-space solids, perceiving them to be not really solids, but boundaries or cross-sections of the solids of his world, the things which he knows to be 3-dimensional, but of which he can see only the outside. By analogy, from a 4th dimension, these same solids would in turn appear transparent and be perceived to be but boundaries or cross-sections of 4th dimensional solids. Clairvoyant vision is of this order, indicating that it is 4-dimensional. Seen clairvoyantly, the internal structure of the human body is visible within its casing, also the aura or the higher dimensional body. Plate 20 is showing the magic tesseract generation, Philip Henry Wynne, February 1912. Plate 21 shows the diagram of magic tesseract projection. Introduction to the magic tesseract. The untrained mind finds something especially satisfactory and secure in numerical relations. It easily believes that what is true of 4, 17, or 1001 units must be true of 4, 17, or 1001 apples, miles, or men. The author accordingly invoked the mathematical genius of Philip Henry Wynne to furnish him with some inexpugnable illustration founded upon the properties of number of an open road for human thought into the 4th dimension. The result of Mr. Wynne's diving into the deep waters of mathematics was the production of the magic tesseract, a pearl which anybody is free to examine and admire, but one which only a mathematician can properly appraise. If the reader will follow the ensuing explanation step by step, verifying the relations noted, he will be able to participate without deep knowledge or hard labor in the assurance of the underlying reality of hyperspace which comes to the mathematician of an open mind as a result of his researches. Plate 22. A magic square of 4. The accompanying figure represents a magic square of 4 made by a well-known method. The reader should verify the following relations, for they are not trivial in connection with what comes later. Each horizontal and each vertical column adds 34. Each diagonal adds 34. 4 corner cells add 34. 4 central cells add 34. 2 middle cells of top row add 34, with 2 of bottom row. Similarly, with middle cells of right and left columns, go around the square clockwise. First cell beyond first corner plus first beyond second plus third plus fourth equals 34. Each corner set off by heavy lines adds 34. Take any number at random, find the 3 other numbers corresponding to it in any manner which respects symmetrically to dimensions, and the sum of the 4 numbers will be 34. Plate 23. A magic cube of 4. This drawing represents a magic cube of 4 constructed by a pure extension of the square method of Figure 1, Plate 22. The magic cube of 4 is made up of 64 cubes, each bearing on all 6 faces one of the numbers from 1 to 4 inclusive. Now the cube can be sliced into 4 vertical sections from left to right, as in Figure 1, which shows the sections separated so that the interior summations can be seen. Or it can be separated into other 4 vertical sections by cutting planes perpendicular to the edge AB, proceeding from front to back. Or the 4 sections may be horizontal, made by planes perpendicular to AD. Now, each one of these 12 sections represents a magic square in which each row and each column adds to 130. The diagonals of these squares do not add 130, but the 4 diagonals of the cube do add 130. The reader should verify a few of these summations in each of the 3 sets of sections. Plate 24. A further consideration of magic figures. A detailed study of the magic cube of 4 will serve to convince the reader of the essentially solid nature of the space arrangement and the perfect continuity of the magical properties of number from 2 dimensions to 3. Now, these same numerical properties continue uninterruptedly into the 4th dimension. To fix the idea more concretely, consider the following statements based on the powers of the number 7. Figure 1 represents a magic line of 7. Observe that the sums of pairs of numbers equidistant from 4 is 7 to the power of 1 plus 1 over 2 times 2. Figure 2 represents a magic square of 7. Observe that here the various summations of 7 numbers give 7 to the power of 2 plus 1 over 2 times 7. In the magic cube of 7, the summations are 7 to the power of 3 plus 1 over 2 times 7. In the magic tesseract, the summations are 7 to the power of 4 plus 1 over 2 times 7. The sum in the case of the magic line is not anomalous in that 7 plus 1 over 2 is multiplied by 2 instead of by 7. It is due to the fact that we are adding but 2 numbers together instead of 7 numbers, as in the other cases. If we took all 7 numbers of the magic line, we should have only one sum, and no magical correspondences. Not only such series as 1, 2, 3, 4, but arithmetical progressions in general, geometrical progressions, and other serial functions submit to magical arrangements in dimensions. Plate 25. A magic square of 3, a cube of 3. Observe that a magic line cannot be formed of less than 4 numbers or a magic square of less than 9. Figure 1, a magic cube requires at least 27 numbers. Figure 2, and even with this number, there are many limitations due to lack of scope for numerous combinations possible with cubes of 5 or better of 7. Magic cube of 3, each row and each column of each of the 9 magic squares, 3 squares to each dimension, adds 42. Each of the 4 cube diagonals adds 42. Each of the 6 diagonals of the 3 magic squares, containing the central number 14, and adds 42. Any random line drawn through the center of the cube will cut 2 supercells whose numbers will add twice the central number 14. All these lines are magic lines. Our well-known numbers 1, 2, 3, 4, etc. contain among them 4-dimensional magic paths as real and demonstrable as those in 2 space. A man will often give 2 and 2 makes 4 as an example of perfect certitude. These magic number properties retort on him by challenging his denial of the 4th dimension, which his own well-trusted numbers affirm most insistently. As a footnote, this cube of 3, an odd number, has a central cubelet which gives rise to several interesting properties lacking in the 4 cube. 26. Explanation of the magic tesseract. The attempt will now be made to render clearly intelligible Mr. Wynn's magic tesseract. The reader is urged to verify for himself the summations particularly specified and the various other relations pointed out. A detailed study of the figure will result in the unfolding of some of the amazing and beautiful interrelations that lie outside 3-space horizons. First, we must consider the symbols and conventions used. Instead of the usual magic square diagram of figure 1, the arrangement of figure 2 will be employed. In Figure 2, the numbers may be imagined to be enclosed in crystal spheres supported on a wire framework, which allows us to see into the interspaces. The wires may be bent aside if necessary and are supposed to be capable of extension or shortening at our pleasure. Though not spontaneously elastic, Plate 20 represents 6 rectangular prisms stretched out from originally cubical form by the extension of the blue and the yellow wires. This distortion is, of course, to exhibit the numbers more clearly, and the prisms should be conceived as pushed back after inspection into their proper cubical forms. Remember then that red, green, blue, yellow wires are normally of exactly equal length. Further, see Plate 20. Our red stands for motion to the right. G green stands for motion towards the G ground or downwards. B blue stands for motion B backwards away from us. And Y yellow stands for motion in the positive senses of the fourth dimension into Y Yamapura. Plate 27. The magic tesseract continued. Now turn to Plate 20. Consider the sphere containing 37. Let it move to the right along the red line, leaving at equal intervals like spheres for 62 and 24. There are then 3 spheres, this being a 3 tesseract. Observe that 3 plus 62 plus 24 equals 123. The magic sum, 1 plus 81 divided by 2 times 3, or more generally, sigma equals n plus n to the third power divided by 2. The correct sum for a 4-space figure, as in Figure 1. Next, the line 37, 62, 24 shall move downward towards G ground along G green lines, leaving 2 similar lines, to wit 9, 49, 65, 77, 12, 34. Each line yields the magic sum 123. So also do the 3 vertical lines. We therefore have a magic 3 square, Figure 2. This square shall now move B backwards along B blue paths, leaving 2 similar squares and generating the first stretched out magic 3 cube, which we will call 37 through 74. Note that all the blue lines, as well as both the old and the newly generated red and green lines, give the magic sum 123, as in Figure 3. The diagonals of the magic square and the magic cubes do not add 123 except when they cross the center of the tesseract. All 8 of the tesseract diagonals do add to 123. Both of these facts are as they should be, though the higher relations, which are the causes, need not be expounded here. Plate 28 continues with the magic tesseract. Now we will take our long leap out into the dark. Let our first cube, 37 through 74, move off perpendicularly in the plus sense of the 4th dimension, leaving in 4 space 2 similar 3 space cubes and generating the magic tesseract. The paths of the crystal spheres are symbolically represented by the system of lines designated as yellow. If we really have achieved the magic tesseract, then every red marked wire 1, green wire 2, blue wire 3, yellow wire 4 must bear 3 numbers yielding the magic sum 123. This will be found to be the case. Observe that all 4 dimensions are perfectly equiponent. For clearness, the wires marked blue and yellow have been stretched, but this might have been done to the red and to the green instead when the tesseract has been pushed back into undistorted form. The red, green, blue, yellow wires are all of equal length, and each of the 108 wires carries 3 numbers whose sum is 123. This being so, who shall say which dimension is more real than the others, and why? Thus is the magic tesseract generated. Let us now see if we can confirm our somewhat analytical consideration by collecting our results in a more imaginable form. In short, let us try to project back from four space the concrete assemblage of the numbers which constitute the magic tesseract. We find that we can. The result is shown in plate 21. The tinting will suggest to the eye an outer and an inner cube, which are respectively 37 through 74 and 08 through 45 of plate 20, A and C, figure 1. But the reader must also imagine another cube, 7804 of plate 21, B, figure 1. Halfway between the other two, C, 78, 35, 66, 07, 47, 16, 75, 04 in the projection also. Plate 29, the magic tesseract concluded. The reader should satisfy himself by trial that every line in plate 20 has its corresponding line in plate 21. Also that each line of the 108 in the projection carries the same three numbers as the corresponding line of the 108 in the generation. The following points are important. It is purely arbitrary which cube is put apparently within or without. They are really side by side in four space and merely appear to be contained one within another, exactly as in a perspective sketch of a three-space room interior. The parallelogram of the further wall is apparently contained within that of the nearer. Figure 1 illustrates this, and also another important point, viz. That the apparently slanting lines and planes of the tesseract are purely an illusion of perspective. In Figure 1, A, F, B, G, etc. are part of a system of three sets of perpendiculars, though they appear to slant, while AB appears perpendicular to AD, etc. Further observe that it was the exigencies of representation that compelled in the projection the placing of sphere 79 inside of 41, and that inside of 03 they really fall one behind another in four space. It is interesting at the point to identify a few of the tesseract diagonals and to verify their summations, just as in Figure 1. A diagonal extends from one corner of the outer square across the central to the opposite corner of the inner. So in the tesseract, we pass from the outermost cube corner to the opposite corner of the innermost cube, crossing and including the tesseract center. Sphere 41, thus 37 plus 41 plus 45 equals 123. 18 plus 41 plus 64 equals 123, etc. The foregoing will suffice to explain these sketches and enable the reader to examine the curious assemblage of concepts and relations which constitute the magic tesseract. Plate 30. The projections made by a cube in traversing a plane. A represents the series of cross sections traced by the cube in entering the plane vertically by one of its angles. B represents the series resultant on its entering by one of its edges. C represents the unchanging cross-section traced by the cube meeting the plane squarely by one of its sides. All possible projections are modifications of these three classes. The cubes in the above diagram, symmetrical solids of a three-dimensional space, trace various ephemeral and changing cross-sections in the plane D. A two-space, the character of the cross-section being determined by the angles at which the cube meets the plane. If the cubes be taken to represent the higher selves of individuals in a higher space world, the plane, our phenomenal world, the cross-sections would then represent the lower space aspects of these higher selves, personalities. Man, the Square, a Higher Space Parable. A quote from Mysterium Cosmographicum by Kepler. Artful nature has given to the most perfect animal the same 6 limits as the cube has, most perfectly marked. Man himself is, as it were, a cube. Man, the Square, the cube and the square. The phenomenal world receives its culmination and reflex of all in man. Therefore he is the mystic square in his metaphysical aspect, the tetractys, and becomes the cube on the creative plane. Quoted from The Secret Doctrine, Volume 2, page 39, 3rd edition, H.P. Blavatsky. And another quote from the Book of Revelation of St. John the Divine, chapter 21, verse 16. And the city, the New Jerusalem, lieth foursquare, and the length is as large as the breadth. The length and the breadth and the height of it are equal. Here are two examples of that order of recondite mystical truths so remote from ordinary knowledge and experience, or else so clothed with symbolism as to be unintelligible to all save the initiated. We are told of a certain correspondence of identity between the phenomenal world and man, and the symbolization of the two by the square. We are further instructed that on the creative plane, presumably some higher world of causes, the square is or becomes a cube. This idea, embodied in the first quotation, is borne out by the statement in the second that the New Jerusalem, the dwelling place of perfected humanity, which might be a world or might be a body, has the length and the breadth and the height of it equal. In other words, is a cube. What meaning lies here concealed? In order to discover it, let us try the experiment of taking the quoted statements not figuratively, as they were doubtless intended to be taken, but literally, and see where we are then able to come out. With the simple-mindedness and confidence of children, let us picture to ourselves the phenomenal world, not as symbolically, but actually a square. The square should not be conceived of as purely geometric plane, i.e. having no thickness in the third dimension, for in that case it would have no physical existence. It should be thought of rather as an almost infinitesimal thin film of matter separating two portions of the cube, its higher space world, from each other. In other words, a cross-section of the cube. Fix this image clearly in mind. The creative plane, that is, the archetypal world, or world of causes, a crystal cube like unto clear glass, divided midway by an iridescent film. The phenomenal world, made up of matter in a different state or condition analogous, let us say, to oil on water, or to the bubble which sometimes appears in the neck of a bottle, as we did in illustration 1. Macrocosm and microcosm. This crystal cube would then represent the macrocosm of which man, archetypal man, is the microcosm. As is the great, so is the small. As is the outer, so is the inner. We must conceive of the great cube as containing many small cubes, replicas of itself in everything except size. Nothing is great, nothing is small. This difference in size between the great cube and the small ones need not disturb us. It has no importance, for if the small cubes are conceived of as themselves containing still smaller cubes after the manner in which they are contained within the great cube, then every part of each has its correspondence in the other and is capable of being expressed by the same ratios. If the great cube were shrunk to the size of one of the small cubes, there would be no difference whatever between them. If, on the other hand, the small cubes were expanded to the size of the great cube, the same would be true. This relativity of space magnitude, a difficult thing to understand by minds untrained in philosophy and metaphysics, is apprehended unconsciously by everyone in such a concrete exemplification of it as is afforded by photography. For example, at a moving picture exhibition, we never think of the image on the screen as being essentially different from the photograph from which it is projected, though the difference in spatial extension is enormous. All that matters is the relation of parts to one another, and these being identical, the question of absolute size does not even enter the mind. The small cubes should be thought of as moving about within the limits of the great cube, such motion bringing them repeatedly in contact with the filmy plane which corresponds to the phenomenal world. They would register their passage, though the matter of this film world, by tracing in its countless cross-section of themselves, if, as has been assumed, these small cubes correspond to the higher or divine selves of men, identical in form and substance with the great self, their Father in heaven, then each transit of each cube or individual through the film square would be for it a physical incarnation, and the correlated succession of cross-sections which it traced in any one transit would represent one phenomenal life. Attributing consciousness to the individual cube, to its totality, and to its every part, that aspect of consciousness stirred from latency to activity by contact with the matter of the film world is passing through it during one phenomenal life, would constitute the personal consciousness. Birth and death. Each personality, each new projection of the cube in the plane would be born, so to speak, with the cube's initial contact with the film, since only thus and then could personal consciousness arise, and each would disappear or die with the final contact. The stream of impressions would be, as ours is, linear, i.e. successive, a constant becoming. All things would seem to be vanishing irrevocably into the void of time. There would be no survival, no immortality, for the personal consciousness on its own plane of manifestation, since the film matter which gave it, for the moment, form would flow together and shape itself into new and different figures, the cross-sections of other cubes, new personalities. With the cube, the true individual, the case would be different. The cube would know itself not to be born nor to die. Each of its personalities, or the tracings which it made in passing through the film, would inhere within it, since every conceivable cross-section is embraced within the cube itself. It would neither gain nor lose them by passing through the film. It would only manifest them in the matter of a lower spatial world. The cube consciousness, individual, would embrace all cross-sectional consciousness, personal. It would have full knowledge of the film world, since it would apprehend that world from a higher region of space. But the cross-sectional or plane consciousness, a fragment, as it were, of the cube consciousness, would depend for its knowledge of the things of its world upon the constantly shifting line bounding the plane figure traced in the film by the cube in passing through. This line would be its vehicle for sensation. What report would such a vehicle make to the indwelling personal consciousness? What notion would that consciousness get through this channel of its world and the things of its world and of the higher world? Film phenomena. In order to answer this question at all adequately, it will be necessary to know something more of film phenomena, to go into a more detailed analysis of the transit of solids through a plane. Picture, if you please, these thousands of little cubes streaming, so to speak, through a plane, meeting it at every possible angle and tracing cross-sections of themselves in transit, in the same way that the surface of a liquid traces the successive cross-sections of any solid introduced into it, as the fluid separates and flows together again. A moment's reflection will make plain the fact that the cubes, although identical in shape and size, would create plane figures widely divergent from one another, the differences being caused by the variation of angle at which each individual cube happened to encounter the plane. Illustration 2. If, for example, a cube entered by one of its corners with its longest internal diagonal perpendicular to the plane, the first presentment of it would be a point, the meeting place of three adjoining faces. The trihedral section bounded by these faces would then trace itself out as an expanding equilateral triangle until the three lowest corners of the cube became involved, when this triangle would change, by reason of the truncation of each apex, into a hexagon with three long sides and three short ones. The long sides would grow shorter and the shorter sides longer as the cube continued its descent. There would be a moment when all six sides were of equal length, after which the forms would succeed each other in an inverse order, the hexagon changing into a triangle, which would shrink to a point and disappear as the cube passed beyond the limits of the plane. If the cube should enter by one of its edges, the first presentment of it would be a line, which would thicken, so to speak, into a parallelogram, whose long sides in ensuing motion would remain constant, and whose short side would lengthen until they exceeded the other two by the amount that a parallelogram expressing the diagonal plane of the cube is longer than one of its square faces. This maximum attained, the section would shrink again, the changes occurring as before in an inverse order, ending as they began, in a line and an evanishment. Only in case the cube should happen to meet the plane squarely by one of its faces, that is, perpendicular to the plane, would the resulting cross-section undergo no change throughout the period of transit. In this case, the tracing would be a square. See illustration 3 and see also plate 30. Now, the angle at which the cube could meet the plane might vary almost infinitely, and each variation would result in a changing cross-section of different form, though every one of these would be referable to one of the other of the three general types described above. If the cubes descended not vertically but obliquely, the plane presentments of them, besides waxing and waning and changing their outline, would have, in addition, a lateral motion, great or small in proportion to the obliquity of the cube's orbits, and thence too would arise a difference as to the figures in their duration. Plain wisdom. Suppose we seek out the most intelligent inhabitant of this flat land, and limiting our perception in the way his would be limited, share his consciousness. This flatlander we will name Plain Wisdom, since he is of both an observant and a reflective turn of mind. Looking upon life and the world, the perpetual flux of things would perhaps first and most impress him. No rest, no stability, no finality anywhere. He would perceive himself to have come mysteriously out of the nowhere into the here, quickly developing lines and angles, doomed presently to wane and disappear. And all of this kind would seem to be afflicted with a similar destiny: birth, a short perturbed existence, ending in dissolution. Of course, Plain Wisdom would not have an accurate knowledge of the true nature of all his fellow plane beings, for his knowledge could come only from the standpoint of the higher dimensional space. But in his transit, he could examine the enclosing lines and angles of his fellow plane beings, and from these form some approximate notion of the distinctive characteristics of each. He would conclude that although every man was different from every other, they all had characteristics in common. All passed through certain recognizable phases in approximately the same space of time, a period of increment or growth, the attainment of a maximum, a phase of diminishment ending in disappearance. He would observe that some developed more varied outlines than others, making them lead troubled, irregular lives, such as began as a point being more unhappy than those which began as a line, because in the latter case, though one dimension changed, one remained constant. In those rare instances in which all four boundaries appeared at once, of equal length, a serene and unperturbed existence was the result. Now suppose the Plain Wisdom, wishful for this untroubled, equable life, should attempt to develop his changing irregular polygon evenly and symmetrical like the square. Failing in every effort to modify his perimeter, he might conceive the idea that a change of contour could be brought about only by a change of consciousness. He would recognize a distinction between his body and his consciousness. Though his body was confined to the plane world by the conditions of his existence, this limitation need not necessarily extend to his consciousness. This consciousness he would realize to be within him. Yet, who could say that it was on that account confined to the plane which constituted his world? What if there were an unknown direction at right angles to the two known to him in which his consciousness were capable of rising? The third dimension, in point of fact? Imbued with this idea, he might succeed, by an act of faith and by an effort of will, in uniting, after a fashion, his personal consciousness with his cube consciousness and endowed with a new and mysterious power. He might react upon his perimeter in such a manner as to change it from an irregular polygon into a square. This would produce a result in the higher world of which he could not but be unconscious, namely, that of bringing the vertical axis of the cube, his immortal body, perpendicular to the film, as in illustration number 4. plain love, plain beauty. Plain wisdom, being somewhat of a philosopher and a mathematician, a practical occultist as well, his studies would tend rather to separate him from than to unite him with plain humankind. Let us think of his neighbor, plain love, as less intellectual, more emotional. Living so largely in his affections, the idea of withdrawing himself into his interior higher self, and so effecting a symmetrical development, would not even occur to him, and if it did, would not attract. He would only achieve the symmetrical form in a different manner. Loving his fellow plane beings, he would feel an inclination toward them, an attraction between his perimeter and theirs. The fulfillment of this love would be in contact juxtaposition. If one of his angles touched one of the sides of another, the resulting satisfaction would be ephemeral and slight, but the cleaving of line to line would effect a union not so readily nor so soon destroyed. Length of line being the gauge of felicity, the contact of the four sides of a square with the sides of four other squares would represent an absolute maximum. In the endeavor to attain the realization of his dimly felt ideal, that is, in multiplying his points of contact with his fellow plane beings so as to prolong all of his lines equally and to the utmost, plain love, in obedience to the universal law that one becomes that which he persistently admires and desires, would transform himself from an irregular polygon into a square. This change of outline would have the inevitable effect of altering the angle of inclination of his cube to the vertical, thus bringing about the same result achieved by the plain wisdom through an intellectual process accompanied by a volitional effort, namely a symmetrical development, a life free from mutations, as in illustration 5. Let us imagine plain beauty to have a personality still different from the other two. The thing which would trouble him in life would be not so much its evanescence, its futility, as its death of ordered and formal beauty. The square would excite his admiration on account of its symmetry, 4 equal lines, 4 equal angles, and the persistence of this one most perfect form throughout the entire life. By dwelling on the unique properties and perfection of the square, plain beauty also would shift the center of his being in such a way that his higher or cube self would bring 4 of its sides vertical to the film world, and so his cube would trace out a square in the matter of that world. The 3 wise plain men, plain love, plain wisdom, and plain beauty, are self-made men of a plain world. They have become what they are by the way in which they have faced the world, incarnation after incarnation. At last, by learning to meet life squarely, they have arrived at a serene and equable maturity. Drawn together by the pursuits of a common ideal achieved by each in a different way, they incline to and become attached to one another. For their lines being in contact, so also, without their knowing it, are the square faces of their cubes. This gives them a community of consciousness which others do not share, but they find themselves unsatisfied for all their philosophic calm. What pleasures can a wise man take in a world of fools? They ask one another. A loving man in a world where people are indifferent to one another, an artist in a world so full of irregularity and imperfection. Even if all men were as they, still would the riddle of life be as far from solution as before? Their coming into the world would remain a mystery, and death would be the inevitable end of all. Is there no immortality, no rest, no peace, no knowledge, no perfection anywhere? Sadly, they ask themselves these questions, raising their plain, bound thoughts to the seeming void above them. They earnestly desire that some mighty teacher, perfect in wisdom, beauty, and compassion, may come and solve for them the riddle of their painful earth. Illustration 6. The light of the world. From its bright and shining sphere, a pure ray of the one light gives heed to this prayer of the 3 plain men. By reason of having passed through crystal prisms without number, it has learned the rainbow's uttermost secret, and is therefore free from the necessity of refracting itself in substance, which, by impeding, reveals the latent glories of the one light. Looking down upon the cube, like unto clear glass, it beholds deep within the insubstantial pageant of the film world, in which men are but shadows of their higher or cube selves, of which they are unaware because their consciousness is centered in those lower dimensional presentments of themselves. It takes note of the united desire in the hearts of three of these tiny and transitory figures. It is aware of their lonely struggle towards the only perfection that they know, and perceiving that the time has come for the great renunciation, it leaves the bosom of the Father, the white light, to show forth his glory in a world darkened by ignorance and death. It enters one of the little crystal cubes, and shattering it along certain of its edges, folds its 6 faces down into the film world, so that they lie there in the form of a cross, a 7-fold figure, 4 squares lengthwise and 3 across. Thus it crucifies itself upon a matter that by its broken body it may manifest to plain men as much as they may apprehend of their higher or divine selves. This body of Christos, though so poor and limited a vehicle for the divine consciousness within, is nevertheless glorious compared with the most perfect plain human form. The square, for it is not 1 square, but 6, each representing a different aspect of the higher self, as illustration 7. The square, its perimeter cut at and folded down into a lower spatial or linear world. The cube cut as to its bounding surfaces along certain edges and folded down into a lower spatial or plane world. The 3 wise plain men, having seen this descending ray as a star in the east, worshipped the incarnate Savior of the world at the place of his nativity. Equipped with all knowledge, full of compassion, clothed in that transcendent body which had been broken for plain humankind, this Christos of a lesser world in due course gathered disciples about him, square men all, save one, to whom he taught the precious secret of release from birth and death. When his work was accomplished, he ascended into heaven, folded himself up in his higher space form, and became once more a ray of the one light, having committed the spreading of the truth to those whom he had instructed. The Sermon on the Plain. One of his discourses has been preserved. Rightly interpreted, it will be seen to be in curious accord with the teachings of every world Savior. For through all their utterances runs an eternal unanimity, the same in all ages, places, spaces. This is the Sermon on the Plain, preached to the plain men by him who was crucified. Heaven is all about you, a city lying 4 square, clear as glass and filled with light. Here your real, your immoral selves have their true home. This world of yours, which seems too substantial, is but a mutable and many-colored film staining the bright radiance of this crystal heaven. Your lives are but tracings made by your immortal selves in the film world. How shall you learn the way to this heaven of light, the truth of this transcendent existence? I am the way, the truth, and the life. This is my body broken for you. This cruciform figure formed by these 6 squares is not my immortal body. The squares are but the boundaries of it, folded down into a lower dimensional world. When my mission is accomplished and I ascend again into heaven, I shall refold these squares into a single symmetrical figure, my heavenly body, a solid of the higher dimensional space beyond your perception. Hearken to the truth, because these squares are solids of your world. It is hard for you to understand how they can be boundaries of a higher solid. In order to understand it, imagine for a moment that your world, which is 2-dimensional, is the higher space or heaven world of a 1-dimensional space. The perfected body of a plain man is a square. Suppose you wanted to give some idea of the square, which you are, to a consciousness limited to the one dimension of a line man. First of all, you would have to lose your solidity, forsake and forego your inner or plane life, which for you is the only true life, and confining your consciousness to your perimeter. Break it at one of its angles and fold it down, straighten it out into a one-dimensional space. Its four divisions, each one the boundary of one side of the square, would be, to the perception of the line man, a solid of his space, and he would have the same difficulty in imagining them folded up into a single symmetrical figure that you have in imagining these six solids of your space to be the boundaries of a symmetrical solid of a space higher still. See illustration 7. Each of you has this heavenly or cube body, which you must think of as related to your physical or square body, as that is related to one of its bounding lines. The cube is the true individual, of which the square is but a single illusory and inadequate image. The individual expresses itself in countless of these personalities, each one a tracing of itself. The sum total of all possible tracings is the cube itself. Birth and death are illusions of the personality. For the cube, they are not, since it did not begin its existence with its first contact with the film, which is your world, nor will that existence cease when it passes beyond that world. Neither does the changing cross-section which it traces in thus passing comprise or comprehend its life. Time and change are illusions of the personality. The cube knows neither increment nor diminution. All conscious cross-sections inhere within it all possible forms of the film world. It is their revelation only which is successive, giving rise to the temporal illusion. Learn now the precious secret of immortality. The consciousness within the cube and within the square are one consciousness, and that consciousness is divine. It is possible, therefore, to identify your plane consciousness with your cube consciousness and rise by such means into the higher dimensional world. This is achieved by desire, by work, by knowledge, by devotion, but more than all by love, as you shall learn. Because each individual traces in the film world a different figure, determined by the angle at which it meets the film, by its attitude toward life. You are all under the illusion that each person is unique and singular, that some are better and some worse. But these differences are accidental. They do not exist in the heaven world, where all are God's children, and may become one with the Father. Live uprightly, love and cleave to one another. By so doing, you will make vertical and parallel the axis of your higher or cube bodies, and as the sides of your square bodies cleave together, so will the faces of your cube bodies coalesce. By loving your neighbor, therefore, you are laying up treasure in heaven. For two cubes can unite their faces only when the lines of their square sections are similarly joined. Love effects this junction. When cubes conjoin in mutual love, the individual is transcended, the consciousnesses merge into one, and a larger unit is formed. This process may go on repeating itself, so that if love should become the universal law of life, the aimless drift of souls would cease, for all would enter the great peace at last. All having united into one great crystal cube, the heavenly city, the film world would vanish. The white light would shine unobstructed through the city of the Lord. Illustration 8. It is thus that consciousness becomes self-conscious. It multiplies itself. Each unit in its cube body attains to a realization of its form and structure through the many tracings that it makes in physical matter, the film world. Each transit being an incarnation, a personal life. The events of each life seem, to the personal consciousness, to slip away into nothingness, never to be recovered. But every experience of every film life, all of its contacts with other cubes, are indelibly impressed upon the higher body, and by the cube consciousness may be recovered at will, since all inhere in the bounding planes of the cube. For this reason, when the cube consciousness is attained by the personality, the memory of past lives is recovered. All lives may be lived over again as vividly as before. The indwelling consciousness has only to seek out, in the boundaries of its cube body, the particular point or line of contact with the film world in which the vanished event adheres. More than this, when any cube unites with any other, the indwelling consciousness of each, overpassing its normal limitation, is able to share in all of the past experience of the other as though they were its own. By multiplying these contacts until all the cubes coalesce, each individual consciousness might share the experiences of every other, from the dawn to the close of the cycle of manifestation. This is Nirvana, the Sabbath of the Lord. These things I have spoken unto you, that in me ye might have peace, that all may be one, and that they may be made perfect in one. My peace I give unto you. The interpretation of the sermon. This elaborate paraphrase of familiar religious teachings needs no further elucidation if the reader has had the patience to follow it up, step by step, raising, as he did so, everything one space, that is, conceiving of man, the true individual, as a higher dimensional entity manifesting itself in a three-dimensional space, through and by means of the forms and conditions proper to that space. To show how curiously in accord the higher space hypothesis is with the teachings of the ancient wisdom of the East, this essay will close as it began, with the quotation from Madame Blavatsky's The Secret Doctrine. The real person or thing does not consist solely of what is seen at any particular moment, but is composed of the sum of all its various and changing conditions from its appearance in material form to its disappearance from earth. It is these sum totals that exist from eternity in the future and pass by degrees through matter to exist for eternity in the past. No one would say that a bar of metal dropped into the sea into existence as it left the air and ceased to exist as it entered the water, and that the bar itself consisted only of that cross-section, therefore, which at any given moment coincided with the mathematical plane that separates and at the same time joins the atmosphere and the ocean. Even so, persons and things, which dropping out of the to-be into the has-been, out of the future into the past, presently momentarily to our senses, a cross-section, as it were, of their total selves, as they pass through time and space, as matter, on their way from one eternity to another. And these two eternities constitute that duration in which alone anything has true existence, where our senses but able to recognize it. And this is the end of the reading of the book titled A Primer of Higher Space, The Fourth Dimension by Claude Bragdon. If you haven't done so, please do hit the like button, share this with like-minded people, leave a comment, let me know you were here, and yes, subscribe to the channel.